Greetings and welcome back. What we're going to do in this video is having a look at the graph of this function y equals f of x. We're going to try to sketch the graph of its derivative. And remember, with these graphs, we're only really focused on the shape of the graph. We're not necessarily focused on specific values of x, although that can be helpful. And notice how I have my axes positioned. I draw my blank graph below the graph of f. That way we can easily correspond the common values of x for the special points on the graph where we know the value of the derivative. So remember that the easiest points to spot on the graph of a function are where its horizontal tangents are. And I'm going to label them with points right here. So that means at the same value of x, I know the value of the derivative is 0, which means at those points, the graph of the derivative is right on the x-axis. So what else is happening on this? Well, we notice that there is a cusp in between the horizontal tangents, which suggests that the derivative is going infinite, undefined derivative. So that means that we're going to have a vertical asymptote at that same value of x. So let's reconcile what's happening up to the asymptote. So starting with the left-hand horizontal tangent, notice that the derivative starts out at 0, the slope of the tangent line starts out at 0, and as you move toward the cusp, these slopes are getting more and more and more negative. So that means that the graph of the derivative is under the x-axis and moving in a very sharp decreasing direction. Now, what's happening between the cusp and the other horizontal tangent? Notice that if you start at the horizontal tangent, the slope is 0, and then these slopes are positive, but getting much more positive and much more sharp as you get closer to the asymptote. That suggests that the derivative graph is going to look like this. Okay, so then what's happening on the other side of those maximum points, the horizontal tangent points? Well, as you go to the left of this horizontal tangent, notice that the slopes are positive, and as you go to the left, the slopes are getting steeper and they're positive. So that means that we're going to have something like this. The slopes are positive and getting steeper, which means they're increasing in value. And to the right of the right-hand horizontal tangent, notice that the slopes are negative, so that means this is going to punch through the x-axis. But then notice as x goes to the extreme right, those slopes are getting closer to 0, which means there is a point where the slope is where we're going to say most negative, I guess you could say. And then the slopes come back up to get closer to 0. So there is our best guess at what the graph of the derivative looks like, because we don't know what the equation of the original function is. But based on the properties, this is our best guess.